Hello everyone, welcome to this video where I'm going to show you how to derive the formula or verify the conjectures for all the formulas that we learn in Form 4 Additional Mathematics. So the first formula we're going to learn comes from Chapter 2, Quadratic Functions. So derive the quadratic formula. So here we want to try to derive the quadratic formula as shown on the screen by using the completing the square method. And we're going to start by using the general form of the quadratic equation. We will move c to the other side to get ax squared plus bx equals to negative c. And then to use completing the square methods, we always have to make sure the coefficient of x squared is 1. Hence, we have to divide all the terms by a. Okay, divide all the terms by a like this. And hence, we will get x squared plus b over ax equals to negative c over a. And notice that I leave out the space here because this is where we are going to add the terms. What are the terms? We are going to add the coefficient of x divided by 2 and the whole thing squared. Okay, the coefficient of x a over b divided by 2 squared. We are going to add this to both sides of the equation. So it looks something like this. X squared plus b over ax here. Then we have plus b over a to the power over 2 to the power squared, and here b over a over 2 to the power of 2. And to further simplify this part, b over a divided by 2 can also be written as b over 2a. Okay, so this one will be further simplified to b over 2a. Okay, I'll have to stop the video here for a while because while I'm doing my editing of the video, I found that I have replaced this step with this step here. So I think it is better we leave this step here in as a part of our solution. Okay, leave this step before you move on to this step and the following steps which I'm going to show with the video. Sorry about that. And the next step will be filling in the brackets to the power of 2 here with this term and this. So it becomes x and b over 2a, positive b over 2a. Here remains. For the right hand side, we try to simplify this. So it becomes c over a plus b squared over 4a squared. Since the denominator is not the same, we try to multiply this by 4a such that the denominator are the same. So if you multiply the denominator by 4a here, you have to multiply the numerator by 4a as well. So you will have in a single fraction as shown. Next, I'll rearrange this half. For the next step, we are going to move the square to the other side. Hence, it becomes. So since 4 and a squared can be simplified by the surd, hence we can write this as plus minus b squared minus 4ac over 2a. For the last step, we move this here and you'll get x equals to, and since the denominator is the same, we can write this as a single fraction over 2a, and the formula is proven. Then we move on to chapter 4, indices, surds and logarithms, where we have 4 laws of logarithms to prove or verify. okay, which is the product law, division law, or quotient law. The third one is power law, and the last one is the change of base formula. For the first three, product law, division law, and power law, the initial step, the way we start our derivation is similar. So that is the part where you need to memorize. Let me show you. Okay, to start, we always let m here. So we let m equals to the base here, okay, a to the power of another unknown which we ourselves determine. Let's say it's a p, or you can maybe use an x. Okay, if according to textbook, they are using p. Likewise, for the n here, we also let it to equate to a to the power of another unknown, let's say q. Why we are doing this? Because we are going to move the a here. Why we are doing this? Because we are going to let the base of the indices a, we are moving it to the other side so that it becomes the base of the log. So we get something like this by using the basic concept of logarithms. Right? So a here, when we move the other side, becomes log base a of n, which equals to q. So we notice that this is actually this. Okay, this is actually this. So this is the part where you need to memorize. This is the key. From here, then we can start. Okay, so we start from here, mn. So m times n equals to m times n equals to a to the power of p equals to a to the power of p times a to the power of q. So you get a to the power of p because m is a to the power of p, n is a to the power of q. By using the law of indices, when you are multiplying indices with the same base, you can add the power p plus q. So mn equals to p, a to the power of p plus q. And by using the same properties here, we move the a to the other side, it becomes log base a of mn, which is now the same as this, equals to p plus q. And what is p again? P is log base a of m. So p is log base a of m, and q is log base a of n. Hence, our law is proven, our product law. Same thing here. We start off by letting m to be equal to a to the power of p, n equals to a to the power of q. Likewise, a moved to this side becomes log base a of m equals to p. Here, same as well, log base a of n equals to q. And we are going to start from this m over n. When m divided by n, we can write this as a to the power of p over a to the power of q. Then by using the law of indices, this is equals to a to the power of p minus q. We move a to the other side, becomes log base a of n minus n over n, and here becomes p minus q, and p is log base a of m, q is your log base a of n. One thing to take note here, if the questions does not use log base a, if the questions use ln, like for example ln m over n equals to ln m minus ln n, okay, so this is the other equation where you are using the natural logarithm, where ln means log base e, okay, log base e. So since we know that ln here means log base e, ln here means log base e, we let our first step, remember our first step here, we have to let m to be this one, a to the power of q, right? E to the power of p. And your n, let it to be e to the power of q, such that when you move the e here, it becomes ln m equals to p. Ln n equals to q. And you proceed. Same thing here. Okay, m over n equals to e to the power of p over e to the power of q. Now we look at the third law. And for the power law, since we only have one term here, we only have to let m equals to a to the power of an unknown p. And when we move the a to this side, it becomes log base a of m equals to p. So after we are done with this, the first step, we start with this, right? We want to start with this. So since m equals to a to the power of p, so when m under the power of n, this is also a to the power of p under the power of n. So you have a to the power of p n. When you move a to this side, it becomes log base a of m to the power of n, which is p n. And remember, what is our p? Our p is log base a of m, so which is log base a of m. But please arrange this such that it is the same as the formula shown here. The n is a coefficient, so you need to rewrite this such that this becomes, okay, so I write it here, log base a of m to the power of n equals to n log base a of m. To prove the change of base formula, the starting step is different now. Okay, so instead of writing this term as another value, we take this, we assume, or we let x to be, or you can use p or otherwise, to be log base a of b. We let this to be x. And the a, when we move to the other side, it becomes a to the power of x equals to b. And now our objective here is to introduce a third base here. So now we can let this to be log base c of a to the power of x equals to log base c of b. And using the power law, we move x here to the front, so it becomes x log base c of a equals to log base c of b. And now this, we can move it here, it becomes x equals to log base c of b over log base c of a. And remember, what is our x? X is log base a of b. And since x here is this, so we rewrite the last step here as log base a of b equals to log base c of b over log base c of a. Okay, for the next chapter, chapter 5, we're looking at progressions. So for progressions, we have 5 formulas. So the first one is from arithmetic progression, where we want to derive Tn, which is the nth term of arithmetic progression. Sn, the sum of the first n terms. Then for geometric progressions, we are going to derive Tn, Sn, and also the sum to infinity. Let's start off with the first one. For arithmetic progression, the list of the terms T1, T2, the second term, the third term, the fourth term. So how do we form the progression? Okay, we start with T1. If you add with D, the common difference, you get the value of T2, the second term. Second term, you plus D, you get T3. T3 plus D, you get T4. Yeah, where D is the common difference. So we are going to list out all the terms here in a more organized way. So we are going to start with T1. T1 is equals to A, and T2 is actually equals to T1 plus the common difference. And what is T1 again? T1 is A. Okay, T1 is equals to A. So A plus D. So we are going to write T1 and T2 in terms of A plus D. Not just T1 and T2, we are going to write the at least 4 terms here in terms of A and D. That is what we want to try to achieve here. Okay, so T3 is equals to T2, the previous term, plus D. But what is T2? T2 is a plus d. So we are going to replace T2 with a plus d. So T2 is a plus d. So a plus d, you get a plus 2d. And we're going to do this for one more time. We're going to show 4. So T4 is equals to T3 plus d. So if you get the idea here, you see that T3 actually, we are going to substitute this with a plus 2d because T3 is a plus 2d here. So T3 is going to be replaced by a plus 2d, and 2d plus d is actually equals to 3d. So we are now left with all of this. I'm going to erase this to show you that T2, T1, T3 and T4 now are all in terms of A and D. So we want to try to find a pattern like what we learned in mathematics form 2. Yeah, find the pattern of a sequence. So whenever you have a running number, we will replace the running number with n. Okay, so T1, T2, T3, T4, we are going to replace with n if we want to find a general formula to replace the sequence here. Then we have A, so all four have A. Now we look at this addition, all this addition, add, and we look at the second term. We have 0D here, we have 1D, 2D, and 3D. So whenever you have running numbers 0, 1, 2, 3, we always replace this with n. But then we find out that this value is always 1 less than the n that we already written here. Hence, this should be written as n minus 1 d. Now, to derive the formula of the sum of the first n terms as n, which is the second formula here, we are going to use the same deduction method, meaning that we are going to list out S1, S2, S3, S4, and then use that to deduce this formula. And for this formula, it is easier if we use a diagram to help us. For example, this one. S1, the sum of the first term is actually T1 itself, which is also denoted by the symbol A. And A can be written as A times 1. And A times 1 can also be represented by this rectangle here, where A is the height and 1 is 1 unit of the length here. And why we are going to represent this in the block form, in this diagram form, it will make sense in a while. So after S1, we are going to look at S2. S2, the meaning of S2 means T1 plus T2. So remember, T1 is being represented by this block, and so T2, we can use the second block to represent it. And since T1 is A itself, T2 now will be A, the first term, plus the common difference, which is A plus D. And so A plus D can also be seen as A plus D times 1 unit. We can represent this by drawing the second block here of the length 1 unit as well, 1 unit here. But the height here now will be A plus D, A plus D. So since A has the same height here, A means D here is the difference between T1 and T2. In the textbook, this is represented by the following diagram, this diagram here. And now S2 is represented by this diagram here. And if we copy and paste this, if we rotate this 180 degrees, you will get this diagram. And then we put it on top here, so that we combine both of the diagram, we will form a rectangle. And this rectangle here, remember, has a length of 1 unit here. Here is 1 unit. And here is A. Here is A plus D because of the second term. So now this rectangle, if you want to find the total area of this rectangle, we take the total length times the total height, the width times the height. So the area of a rectangle can be represented by this, which is actually the height of T1 and the height of T2, which is A plus A plus D. So A plus A plus D multiplied by the length, or the length here, which is 1 plus 1, which is 2. And I put the 2 in front here, you get 2A plus D. And since S2 only considers the addition of T1 and T2, we are going to divide this into half, okay, because we only consider this one, we don't need this, okay, so we only need this one. So we need to divide the area here by 2. So here this have to be divided by 2, so S2 equals to 2A plus D divided by 2. We will not simplify this for now, so that later we can look at the pattern. So far we already formed S1, which is A, and we form S2, which is this. We are going to come back later after we form S3 and S4. So next we have S3. So S3 means T1 plus T2 plus T3. But then we are going to form S3 as what we did to S2 just now. We are going to represent all the blocks here. So the first one here, T1, has a length of 1 with a height of A. T2 will have a length of 1 and the height of A plus D. And T3 will have A plus 2D here, and here is 1. And when we copy and paste this block here, we form 2. And if we rotate the second one, if we rotate this one, we'll get this. And we can combine this with the first one and to get a rectangle. Again, here you will see that this has a height of A, this has a height of A plus 2D. Here is 1, 1, and 1. If you are looking for the area, it will be the height of this A plus 2D multiplied by the length here, which is 3. So I'll get 2A plus 2D. And again, since we are only consider the half of this, we only need half of this. And again, since we are looking for S3, S3 is T1 plus T2 plus T3, which is only half of this. We take this, divide it by half. So you have 2A plus 2D over 2. So now if we refer back to our previous derivation of S2, S2 is equals to this. And so by using the same method of drawing the blocks, we can find S4, which is equals to 2D plus 3D over 2. And from here, we are going to start to deduce Sn. We see that the running numbers here, 2, 3, 4, which is n. And we notice that the 2 and the 2 here is always the same, this value. Hence, the running number here will replace this by n. And we notice that here is always 2a, always 2a. So we are going to use 2a here. And from here, you can see that the coefficient of d is 1. The coefficient of t is 2. Coefficient of 3 is d. The coefficient of d is 3. Whenever you have running numbers, we always replace the running numbers with n. But this n value here is 1 less than the n here. Okay, 2 is 1 less than 3. 3 is 1 less than 4. Hence, this is replaced by n minus 1. So here you have n minus 1d. Hence, this becomes a square bracket. And of course, the denominator is the same. Hence, this is 2. And in the end, you rewrite this such that it matches the formula given, 2a plus n minus 1d. And we get our formula and our geometric progression.